Okay. So let me know whenever the internet seems to stutter again, or if my voice is breaking, and you cannot really hear what I'm saying. Please, please, please do let me know right away. All right. I hope it's not storm related, but basically the weather outside looks pretty bad, and it's gonna be bad soon. So hopefully that's not related, or at least we should finish our lecture before things get worse. Um, yeah, I mean, you might have heard the noise from my windows too. Um, yeah. All right. So today we'll transition from our lecture 1 to 5, which kind of cover Linux, how to use shell script, how to use regular expression, and how to use Git, right, to do version control. And now we're going to transition into the language called C, right? And to begin, we have a quick announcement related to our assignment 2, which is going to be posted next week, right? Why are we doing that? Essentially, because today is the first day you learn how to use C. So I'd rather have you familiarize yourself with how to, like, a basic C programming, which is the in-class exercise today, and then not in-class exam, sorry, in-class exercise for today before we start assignment 2. And to motivate why you should care about C, because you might have heard that it can be annoying to program in C relative to Python or Java, right? So if you look at a computer that you buy, logically, there are a bunch of logic gates, control signal, and storage. We're not going to go into the detail on how to design a computer in this class, but these are components that, if you think about it, it's kind of like resembling calculator with some programming capability, and you can program functions in them, and you can basically run programs that are useful, right? Then, if you physically look at the component itself, right? These are electronic circuits, right? They consist of transistor, they consist of capacitor, they consist of resistor. And these components are being put together in using a bunch of wires that would basically behave according to your program, right? So if you think about this low level, it's pretty magical in how the program works, right? You have a program written in the high level language. Somehow it runs on a computer by enabling this transistor and capacitor and resistor to work accordingly, right? And basically, there's a lot of things going on in the middle that basically orchestrate the program to run, right? It's a bunch of bits, right? That somehow means something to the computer, so it actually know what to do. And if you look at the computer nowadays, actually it can be pretty diverse, right? This is a picture of a Raspberry Pi, right? Anyone here used Raspberry Pi before or seen it before? Anyone? So if you've seen it or you oh nice, you met a creator of Raspberry Pi. Nice, awesome. So this is like you can think about it as it's like a mini computer that is capable of running Linux. And you can write program on them so that it can control different things. When I said things, it actually can be like input from different sensors, output to different motors that you can control in a robot or whatever, right? You can actually plug in the USB, plug in the Ethernet cable, and plug in the HDMI cable. So it's actually more powerful compared to your typical microcontroller that works in a simple embedded system type of application, right? So these Raspberry Pi is actually much more powerful. It operates as if they are a legit computer, right? Have friends who buy a Raspberry Pi and play with it, and it becomes like their PlayStation 2 emulator. They plug it to the TV, and you can now play PlayStation 2 games on the Pi, right? You can use it for a bunch of other things that would involve in like IoT type of application. How about the GPU? Anyone use a GPU at all here? What do we use the GPU for? Yeah, actually, yes. Everyone these days uses GPU. It actually comes with, uh, it actually comes with every single CPU these days. That is on your laptop, that's on your desktop, right? And what do we use the GPU for? Rendering. That's awesome. So when we render a frame, right? So when you watch a video or when you play games, everything that happened has to be drawn. Something has to draw that image, and that image has to be drawn over and over and over in 1 second. If you have a monitor that's 60 hertz, it means I need to be able to draw 60 images in 1 second, right? So the GPU is actually designed to actually perform this rendering. What else can we use the GPU for? So obviously, when we do this rendering kind of workload, we can use it to play games, right? We can use it to actually watch HD video, right? Watch movies, or even render or create animation, right? What else? What else can we use the GPU for? You can do mining, right? You can do mining and recording too. Yes. Uh, you can use the GPU to do crypto mining, right? Despite how inefficient that is. So I'm not gonna make comments on that. But the GPU actually is pretty popular. I think even now there was a period that it's not as popular because of the profit that you get, but now it's getting quite profitable again. So people use the GPU to do crypto mining as well. What else? Anyone heard about this thing called machine learning? So GPU is actually another common type of processor being used to run machine learning workload, right? Why is that the case? Because they can do certain things really, really fast. The things that the GPU can run really fast are things like rendering, crypto mining, parallel data parallel application, machine learning, right? So if you know the algorithm of a program and if you know the low level language like C, it's much easier to control and use these hardware effectively so that you can get really, really good performance from it. How about cluster? This is a picture from Lawrence Livermore National Lab. This is back in the United States. If you walk into any like supercomputing center or data center that hosts either a high performance program that run on a supercomputer or a data center, right? So anyone know or heard about the word supercomputer before, right? Or not? Anyone here want to like take a stab at what are the application that would be running on this supercomputer? Scientific experiment. Well, you can also do more mining for sure. Yes. AI application, right? Anyone here heard about this AI that beats human in playing Go? The AlphaGo, yes, they are being run in these type of machine as well, right? Um, there's a lot of science that goes into how do you communicate, how do you control the data transfer. Many other tasks are being programmed, right? That's a great question. So you might be curious, like, did you watch the documentary about the AlphaGo before? And you might have seen, right, that they basically code on their laptop, right? SSH. We have, where is our server? Where is our Cisco server? Our system skill server basically is in Mahidol University, right? So these machines are in the lab, and they use the laptop to connect to this machine so they can program and run the code on these machines. It's the same setup, right? So they communicate with the server, say, hey, run this thing. There's no way they can run those on their laptop. Right? No way. Um, so that's why, right? That's why you need this huge server. That's why you need this huge supercomputer or data center, right? For some of you who might have realized we are basically running in headfirst into this global warming pandemic that's gonna happen to all of us in the next probably 50 to 100 years, right? Anyone here scared of that? Because I do actually, right? There's a lot of workload that are being run on this supercomputer to basically try to understand more about the impact of what would happen if humans slowly trying to burn ourselves, right? And what can we do to I guess, to mitigate the effects, right? So that we don't have flood, we don't have big typhoon coming in, right? So these are workload running on supercomputer. On the other end, anyone here use Facebook, Instagram, or any social network before? I believe we all are using some form of that, right? I see thumbs down. So for those type of workload, they're being hosted. The data are being hosted in what we call data center, right? That's where you store the data. That's where, for example, Facebook can do a recommendation system to actually try to figure out, right, what ad should they show to you, so that first of all you don't get annoyed, and for the seller, basically the company that buy those ads, is more likely that the user would click on the ad so that maybe they would buy whatever they're trying to sell, right? These are also the typical application that are run on this type of processor. You see now three types, right? A small computer, GPU, and a big cluster, and now you see your own laptop and desktop. They all look different. They all look different, right? You also have the mobile phone, like an iPhone, right? And these all come with different constraints, right? What are some of the constraints on your iPhone? How many people kind of got sick of how long the battery lasts at all? Or like when some apps are draining the battery faster than another, and you cannot figure out why. Like, this thing can happen. And sometimes, actually, in many cases, you need to look at the system stack as well as look at the function calls, the API calls that these application uses, because some of them are more energy efficient, while some of them are not, right? Energy is another big factor when you program. You can also have another type of computer. Anyone owns a GoPro or like action camera at all? So for those of you who owns GoPro or action camera and use it to stream crazy things you guys are doing, right? You might have realized these things are really compact, and the chip there is kind of really good at signal processing tasks, which is recording the video, processing the video, and uploading the video. Many of these tasks have unique properties as well. So if you know how the program works, you can basically control the hardware, which are now diverse. As you can see, it's really diverse. You don't end up with just a CPU and that's it, right? Back 20 years ago, it's likely that the hardware are not as diverse as nowadays, right? It's likely to be not as diverse. But with the more diverse hardware, you also have to know what to do, right? So that you can be most efficient when you run your program. There's also a lot of improvement on the program side of things as well. We call this like hardware abstraction, right? So as a user, more abstraction would lead to more productivity, right? For those of you who program in Python, do you like it compared to shell script? Compared to shell script, which one do you like more? Python or shell script? Python, right? And I think some of shell script probably broke you because of the amount of question I got. Like we as in me, myself, and the TA team, right? We got from the Discord channel, right? Because there are more features that allow you to program really quickly, right? So these type of language allow you to abstract away the hardware. When you program in Python, you actually have to think about what hardware you're running it on at all. You have to think about that for now, at least for now. So are you thinking, hey, are this going to be run on a CPU or are this going to be rendered on a GPU, right? No, right? There's always like library that would handle that for you, and that's a great concept, right? It's a great concept to have another piece of software that comes in and help you, so that you can focus on the task at hand in Python, right? So in many cases, you might not want to know what instruction in assembly are being run right now because you don't care, right? Whatever run the same code on a different machine, I just want them to work, right? And if you think about it, would you rather program in Python versus in C versus in assembly versus controlling every transistor individually? Which one do you prefer more in this case? Which one might you prefer more? Yeah, lazy for the win, right? So actually it's not lazy in the sense that lazy programming, right? But it's actually because we want to keep developing new features for the user, right? The language that is gonna allow you to deploy those features the quickest, they're good. So let me ask you this, right? Why you should care then? Why you should care about knowing how to use C, right? And now I'm gonna motivate you on why maybe you might want to know how to program in C. So hopefully whatever we're gonna teach you going forward could be useful, right? So there's a bunch of what if situation where Python would be basically useless, right? So what if your code is slow and you try as much as you can to change the algorithm and it's still slow, right? Or your code can sometimes consume too much energy. You develop an app for an iPhone, and then turns out you use that app you developed for 1 hour, your phone battery goes off. That's a bad thing, right? You want to fix that. Or you want to switch to a new computer and somehow the code runs slower, right? Or your program just produce incorrect results and you don't really know, you try to debug as much as you can. You don't really know what happened because you run into system level bugs coming from the OS that are related to certain features that you use in the program, right? Or your code make computer hangs or even restart itself. I did this before in our experiment to showcase that if you don't use the GPU in certain way, you can shut down your computer, right? Um, so knowing how the computer really work can help, right? And C, the language C is like one of the languages that's closest to the hardware, barring assembly. Like you don't have to be in pain trying to read assembly code. Most of the time you can go with C language and it would basically allow you to even go and fix the kernel code in the OS, right? To actually make sure things are correct and to improve the performance. When you run a program, there are many different ways you can improve performance. One of the main techniques that every computer scientist will learn is to change the algorithm. But I can tell you, I think probably less than 10% of the people knowing that you can also change the OS, change the compiler, change things you typically can do to optimize your program as well, right? And this can give you this additional power to compete in a really dense field, right? So that your product wins over the other products by performing better, by being more efficient, right? And to now that I motivate you how like maybe basically why C can be useful, right? The one concept that I really, really want to make sure you are aware is everything that you run on the computer eventually becomes the data, right? So when you run a program, the OS copy the program's binary to the main memory. So anyone heard about the word program's binary before? Binary file. What are those? So have you heard about this before? So these program binary is basically when you, so thank you. They're basically, you heard of it. Basically, these are your program, but it's not represented in the language you've written in. Let's say you write a Python program, right? Then you open the file, it's going to be in Python. But exactly, a binary program is basically is machine readable. You can basically from the machine point of view, it knows, okay, this is the program you're basically trying to run. Data that the program are using is also stored in the main memory. Whenever I said the main memory, these days I'm referring to DRAM. The DRAM that you buy on your desktop and you plug it into the motherboard, these are the main memory. This is also the same thing that comes with your phone and your laptop, right? Whenever it says 8 gigabyte of memory or 16 gigabyte of memory, these are where, whenever you run the program, these are where the program will be located. These are where all the data from the program that are running are going to be located as well. The processor, the CPU core, basically the CPU core, then access this program and the data to basically perform the computation that you are writing, right? So let me go over the high level example by assuming, right, program is in test.c, like you write a C program and you want to run this. This is what's gonna happen. You have the program called test.c. To run this, for those of you who run these kind of program before, what's the first step do I have to do? What should be the first step if I want to run this program? Right now it's in C language. It's not machine readable. Machine look at this C language like, I don't know what this program is. So what should I have? What do I have to do? You have to compile, right? So we are not going to go into the detail of what is a compiler in detail, but basically you can think about it this way. The compiler would take your C code or whatever language the compiler is designed to do. It will take that program, spit out the binary that machine understand. Basically, it will compile and becomes a bunch of bits. So these are the binary of that program. Now, the machine, if it looks at this binary, it knows what to do. So the compiler basically translate as a part of the compiler job, it translates to binary, and it basically also do like a lot of optimization as well. But one of the things it does is translate to binary so the machine can run. And then when you actually run the program, here's your DRAM, right? When you actually run the program, what do you do? What do you do when you want to run the program? You open the terminal, right? And then type something in shell to run that program. So when basically whenever you run the program, you notify the OS, say, hey, I want to run this program. The OS would copy the program, right? This chunk of code, right? It get copied over here. So the same binary is now in the main memory, right? The same binary is now in the main memory. The CPU, which is capable of processing the program, would say, hey, that's the first line of code. So I'm going to run the first line of code whenever the OS tell you to run. So let me ask you this. How many programs do you have open on your computer at the moment? So how many programs are you having it open right now? like 15, right? And how many processor core that you have right now? How many cores do you have? Say 8, right? You see that number of programs is greater than the number of core. So what does it mean? Because one program, only one program can occupy the CPU core. So if you have 15 program, 8 cores, it means that 8 of them can be running at the same time. And the OS would basically pick out at any given time which program to run. All right. The OS would come in and like, okay, at this moment, run this program and this program, run this program on CPU 1, run this program on CPU 2, run this program on CPU 3, etc., etc., right? Based on the priority of the program. Some program are more will have higher priority. For example, if you're playing computer games, right? If you delay your computer games by just a bit, user, which is you're gonna see the pain, right? By either you lose in the games or things like that. These would have more priority compared to just a print job. Whenever you want to print something to the printer, those would have a lot lower priority, right? Because most of the time you don't care. Eventually it will get printed, right? So this is how the OS can comes into play, and the OS also written in C, which means that you can change how these things are done if you know C. And this is basically how you can control many, many components in your computer, right? So C is like a gateway to system, to be honest, to having full control over your hardware. So basically that hopefully that's answer why C language, right? But let me ask about more things. You might have heard about this property that C is really fast, and that's actually true. C is one of the fastest language. Whenever you want to develop a program, right? Given the same algorithm, writing the program in C is likely to be the fastest. So if you want performance, you better know how to write code in C and C++. If you care about performance, this is basically what you do. Another thing is you have a direct control over the memory location, right? Which means that you can manage the memory on your own using basically your manual control. These also allow you to optimize your program even further. And this is pretty minimal. It can be clean if written well. And yes, that's when you have problem with C. Memory leaks is one common problem. Memory leaks is when you keep asking for more memory and you forgot to clean it up. The part that you don't use it anymore. So it's gonna keep asking for more memory, and then your program basically performance would tank, right? So that's the downside of using C. Uh, C is also compact, which means that if you have embedded processor, C is a good language because you can compile into a binary that are small enough that you can put it in this microcontroller. Your microcontroller, depending on the size, some of them might only have 8 kilobytes or 16 kilobytes of the memory. So you need to make sure your program would fit in there, right? So when you want to use a microcontroller or embedded system, they typically would be written in C language as well. Now I see I'm talking about a lot of the upside about using C. How about the downside, right? So why not using C? Well, memory leaks for the win, right? You need to manually manage the dynamic memory, and we're gonna go over this later because this can be really annoying to get it correctly for the first few iteration of writing program in C, right? And it's not object oriented, but you also have the alternative of C++, which basically I'm gonna conclude is not a strong downside of C, right? Because you can use C++ to have good performance while being really fast. And there are many, many ways that you don't even have to be creative to create bugs, right? So if you're not being careful when writing program in C, you're gonna have a super buggy program when you compile. right? And you probably don't want to have a buggy code in general, right? Especially if you're writing the application that can kill people. So in that case, you want to make sure your program is safe and is correct, right? So when you write things in C, it might be not as easy to debug in in some scenario, but it also sometimes it's easy to debug if it comes to the control over the main memory and things like that, right? So that's a pros and cons. So hopefully you buy it that it's a good language to know on top of what you know for now, right? How about C sharp? That's a great question, right? So if you're gonna have to develop code in the like Microsoft environment, C sharp is also useful. To be honest, I used it before in some of my projects, and it feels like it's actually not bad, but it's kind of limited to like Microsoft environment, right? So that's a trade-off right there. And it's closer to Java, to be honest, than C, I think. Right? It's a little bit closer to Java than C++, in my opinion. Um, so it's definitely good to know. Uh, it's not gonna kill your career if you don't know it. And also learning C sharp is actually not hard, right? If you know how to write code in C, you know how to write code in Java, that's pretty much it. You just learn the new syntax and that's it. A lot of concepts can translate over to C sharp. So here are how to write code in C. The first thing I have to kind of go over is how to write a function, right? So most of the time your program it requires function calls. So similar to Java and Python, right? You have uh, a function would compute something and would return a value. Whenever I said returning a value, it's like when the function is done, it gives the value back to whoever called this function. It can also take in an input that has certain type, and the function are physically located in the main memory. And here's an example of how a function can be written. Let's say I want to create a function called add that takes in two inputs called A and B, both are integer, and I add them together and I return an integer. I can write it this way. It starts with the return type. So this is the return type, followed by the function name, followed by this parenthesis. If you want to have any input to the function, put a variable with the type in the parentheses. In this case, you want to have two inputs. Both inputs are integers, so you say int A, int B. And then inside the function body, just say whatever you want to do. And then you return the value. Whenever it hits the return command, it basically would return the value after the command. And to be able to start a program, right, there has to be a main function. So when you compile a C program, the main function is where the first line is going to be run. To do that, you basically declare a function with the name main. That's all. That's how you declare the main function. You basically tell the compiler that's the first line of code, and then basically you put in whatever you want to put in. If you want to return an exit code, then you say it main. If your program doesn't return anything, you can do void main, right? And now you see int, you see different data type. I want to cover a little bit more on the data type, right? This is similar to Python and Java and any other languages. C support multiple data types. Integer, float, and character in particular. And more. We'll get into more types of data in a bit next week. But right now, let's focus on this basic data type. There's a question about what about int main, right? So what about things like int main, argc, I guess int argc and char star argv. This is another format that you can write a main function. This allows you to actually take in the command's input. So let's say your program is called, let's say your program is called test, right? Let's say your program is called test. You can run this by /test with some input, 1, 2, and then I guess a string tester, maybe, right? In this case, the argv would take in each of these input. 1 would be in one of the array, 2 would be in another array. They are both in the character format. It's a string. It's an array of string. So this allows you to basically process the arguments that the user type in. So does it answer your question? If you do int main and then nothing in parentheses, it means it doesn't really care about what you put in for the inputs. If you do argc and argv, argc is the number of input parameters. Argv is the string for each of the input. All right. So does it? Yeah. So basically, it allows you to interface with the command calling. It when you call the command, this would pass down to your program, right? So thank you. Great question. So like other language, C also work with multiple data types, right? You can use int, float, and char. And a quick note is because I say everything is the data and everything eventually turns into a binary format, right? So when you have a character, these are basically ASCII format, which means that if the character value is 5, 65, for example, 65 maps to the letter A in the character format. So if you want to type in A, B, C, the letter A is going to be represented with the number 65, B is 66, and C is 67, right? In char, which is character format. And C only support basic data type. So there's no such thing as a string. There's no string. It becomes an array of character, right? String is an array of character. There's also no Boolean. When you want to use true and false, number 0 would mean false. Any non-zero value means true. And you can define your own complex data type using a special command, which we're gonna learn in the next week. Right now, these are the basic data types, and you can declare a variable similar way to how to use that in Python and Java, right? So you can assign value to the variable similar to Java, but it's a little bit more restrictive in the sense that uh, you can't use b until you declare there's a variable called b, right? So in this case, these 4 lines mean I'm going to create a variable called a and have the value 10, right? So a would have 10. This line means I'm just going to declare b and c, they exist. I haven't actually assigned any value yet. Then now b is 20 and c is going to equal to 10 plus 20, which is 30. So you can use variables in the same fashion. You can assign value to from one data size to another. For example, integer is smaller than a long integer, right? So if you want to assign an integer to a long integer, you can declare another long integer called d, and then you can say d equals b, which means that now d is gonna equal 20 as well. But the data type are different. B is an integer, D is gonna be a long integer, right? B is integer, D is a long integer. And you can convert the data type by what we call casting, right? You can do casting to convert data type. And to do this, you basically say parenthesis data type. This would basically represent the variable as the data type you're casting. As the data type you're casting. Give me a minute, guys. Sorry. So when you're doing this casting, uh, it allows you to convert the type of the variable from one to another. So in this case, let's say A is the character. Int A would represent A literally as a number, right? So when you convert one type to another, for example, you have the integer A equals 12, right? A equals 12 and B equals 5, right? A divided by B is what? So if I do 12 over 5, what do I get? What do I get if I do 12 divided by 5? With an integer number, I'm going to get 2, right? This is going to equal 2. So if I want 2.4, actually, it's not going to give you an error. It's going to give you 2. It would allow you to actually do that division, and you will get the number 2. So if you want to use the floating point format, you cast them to float, right, for both of them, so that this becomes 12.0 over 5.0, which would equal to 2.4, right? It would equal to 2.4. So be careful when you want to convert the data type from one to another. Do you need to cast on both? Let's play around with this during the demo so that you can see. Actually, you don't need to cast on both. Basically, you just need to tie your data type to the operator so that it knows, oh, it's a floating point, right? Typically, I try to be more careful when I cast everything based on the type I want, right? So I write it this way to say, hey, in that case, you don't have to remember, just cast it so that it's clear. Make things explicit, right? Make things clear. Um, so we'll play around with this during a demo. The operator also works like Java and Python, right? You can do A plus B. B plus plus, this means that B equals B plus 1, increment by 1. You can do also plus plus B. The difference between B plus plus and plus plus B is plus plus B in a statement would be done first. B plus plus in a big statement that will be done last. It would be done last, right? So the increment would be done last or first. Division, modulo, equal, not equal, less than or equal. And a quick note is if you want to check for A equals B, make sure there are two equal signs. If you somehow ended up writing this, if A equal B with one equal sign, what will happen is you assign the value of B into A, then return B as a result. So in this case, it's actually likely not intended consequences. This is one of the common things that even myself, I do it once in a while, right? So make sure it's double equal sign. It works with logical operator like not and or, right? So A and B would work like this. If it's true and true, that's true. True and false, that's false. False and true, that's also false. False and false, that's false. Or it basically, if it's true or true, it's true. True or false, also true. False or true, also true. False or false, this becomes false, right? This is basically a logical statement. If you want to use bitwise operator, change the not from the exclamation mark to tilde. The and becomes just one or. There's an XOR and shifting as well. We are not going to go into the details of how this is done because we need to cover binary number first. That's next week. So we're going to cover binary number and play around with this logical operator and bitwise operator a little bit more. This is going to be the content after we are more familiar with C. So we'll cover the basic C first before we go into how to represent data. How does bitwise operator plays in the role in here, right? You can also write comments using the double slash, right? Double slash would allow you to comment one line. This block comment can be done with slash star followed by whatever you want to comment and end with the star slash. You can also use if else, right? And switch case. So you can do if something else, if something, and then else something. You can use switch case. In this case, switch A means that I'm going to check the value of A. If A is 1, you first do B++, followed by another B++, and then break, which is going out, done. If A is 2, you would then do B++, and then break, which is say I'm done. Default means that if A is not 1 or 2, it would do B++. And the default is optional because if it doesn't match to anything and there's no default, nothing is done. You can also declare a loop, all right? And here's the format of the loop. There are 3 parts. I'll call part A, part B, and part C. Part A is the initialization. Basically, do this before you enter the loop. Part B, I'll call this condition checking. If part B remains true, loop around. C is do this at the end of each iteration. Basically, for each iteration, do this. Increment I, increment I, increment I. You can also use while and do while. And there are 2 more keywords that ties to looping. You can use the keyword break to break out of the loop. So basically, if you want to stop the loop prematurely, you type in break, semicolon, it would break out. Then you can also use the keyword continue to skip the current iteration of the loop. Basically, you are done with the current iteration. You want to go to the next iteration, type in continue. There's also printf and scanf. Printf can be done like this. Printf would print something on a monitor. You can printf and then whatever you want to print. And then you can also put in special symbol, right? Special symbol that would determine I'm going to print a variable in my program. In this case, I want to print a number, and you put in the number as an argument to the printf function. So over here, we print hello world and then the number 10. To read from the standard input, you can call scanf, right? And there's a bug here. It has to be ampersand followed by the variable name. In this case, it would read the number from the input into the variable called A. And I'm going to show you how that can be done in the demo, right? And before we wrap up the lecture part, you can then compile and run your code using a GCC command. GCC is the C compiler. So it works with C code. It doesn't work with any other language. It works with C code. And to do this, you do GCC followed by the C code, the name of the file you want to compile, right? And then you can add an option, -O. -O basically would name the output binary to whatever name you put in here. So let's say you do GCC test.c-o test. It will generate a binary program called test, right? Which is a binary. And when you want to run, you can just do /test. In this case, it would run your program, right? So that's it for the lecture part. Before we dive into the demo, here are additional references that you can check out. There's a C manual in the GNU.org. This is basically one of the core manual in the C language. There's also standard library that are useful. It include a lot of useful library that can use in C, like how to do power and a few math operations, including things that how do you deal with generate a random number and things like that, right? Um, then the format string inside the printf, right? The %d, %c, %s, it can be explained through the tutorial in this link. If you want to dive into your own, like basically search on your own, you can say printf format string, right? It would expand into what are the different symbols that you can do, and that actually a part of our in-class exercise 6. But before we dive into the in-class exercise, we're gonna do a demo and write 3 different programs. The first one is the simplest, where write this hello world. Then we do factorial using just either recursion or loop, depending on your choice. And then we do Fibonacci using both loop version and the recursion version. All right, so I'm gonna switch over to my desktop. So I'm gonna stop sharing on this computer, and let me know whenever you see the screen. Can you see a screen that has shell open? All right, awesome. So over here, I have a blank directory that we're gonna write the 3 program together, right? The first program is gonna run hello world, right? So I'm gonna do, I guess, hello.c, right? And as I said, it start with the main function. To print hello world, what should I do? If someone tell me what to do here. Just printing hello world. What do you type in? Yep, that's it. And I want a new line. If I want a new line, I can do \n, right? And let me give you a little bit more example. Let's say I say int a equals 10, and I want to print a on after that as well. Right, so I can do this, right? And if I do this and compile, right, it would actually tell me something. It would basically first give me a warning. I say printf is not defined. Is not defined. It's a built-in function. So note include standard io.h, right? Yes, exactly. So what you want to do is to make sure you include the way you include the library. Library is basically pre-built, right? Pre-built function that you can use a tie with each of the languages you can call. Sometimes there can be an API for different features that you can do, like pull things from a database and things like that. Is part of these include statement. So you include the standard IO. Standard IO, as the name suggests, is a standard input and output, right? Uh, Great question. Should I upload my annotated note as well on top of just the PDF? There's a question whether there's a way to find my annotated notes. I mean, I wouldn't mind. I would just do the annotation. I actually save all the annotation. Okay, sure. I'll upload those too. So I'll upload the lecture with and without annotation for all the lecture. Uh, so over here I include standard IO, which basically means that I'm gonna make sure I have this header file. We're not gonna talk about header file today, but it's a file that include function definition, so it knows how to basically call certain functions that we haven't declared. It would go search standard IO and if check if printf is declared over there. It works the same way with C++, yes. So if you use C++ before, the same standard header file would work there as well. C and C++ is like brothers, right? So it shares a lot of things, so you can use the same. Yes. but it won't have some of the C++ features, right? It won't have some of the C++ features. It's kind of a limited version of that. Um, so what else should we do? Okay, let's do this. So let's do A is 12, B is 5, right? That float A divided by B, right? And let's print C. Printing float is an F, right? So print C. Oh, can string and int concatenate? Awesome question. It cannot. C is too simple. You need to write a function for that. And it actually have a header file called string.h, right? So that's a include that has a lot of built-in function that related to string. You can then first convert, right? Convert the number to string and then concat string and string. So let's compile this program, right? See something? I have floating point A, right? But I do division, but B is not a float. So it gives me a warning that I'm trying to cast a number in integer into floating point. So let's run this. When I do GCC without any argument, it would compile into a.out. So if you run this, you see that the variable C is 0. So let's see why is that 0, right? Why is that 0? What if we do this? Anyone figure why is that 0? There's actually a bug here that you might have missed. Yes. C is not a float, right? What about if I do this? No complaints. And if I run this, what will happen? I'm gonna get 2.4, right? So now let me took away one of the float, right? Let's see what happened. Again, 2.4, right? As I said, you already cast A, so when you see division say, oh, that's a float, so I'm gonna use a floating point division and put the result to C. And that's gonna become 2.4, right? That's gonna become 2.4. So be careful, as I said, be careful with data type so that you know exactly that you're using the correct data type. And if you're using the wrong data type, like for example, if you're using the wrong data type like this, keep in mind of the warning that GCC gives it to you because it actually tell you something. Right? Say, hey, wrong format. Is this what you intended? Because it would allow you to do what you tell them to, right? If I don't want to have the output name hello, I mean a.out, you can do -o hello, right? Now your program is going to be called hello. So you can write this, right? So let's do the next program, factorial. Do you want to implement the recursion version or the loop version for the factorial? Can someone tell me? All right, let's use recursion. So how do you define factorial? What's the function for factorial? So I'm going to define a function called fact, fact, right? That would perform the factorial. How do I write this? All right, help me, class. What do I do? So I'm gonna put in a comment. Fact of I equals what? It equals 1 if I is 1, right? Otherwise, if I is greater than 1, what's factorial of I? What do I put in here? What do I put in this parenthesis? Exactly, I minus 1, right? So this basically I can do this. If I equals 1, return 1. Else return factorial of I minus 1 multiplied by I. Right? And let's test this. So let's do factorial of 5. You see the factorial of 5 is 120, and it's a little bit messy, so I'm going to clean up the print statement here so that it actually have a new line. And let me compile again, right? Let's put in number 6, right? This should be 720, right? So it's returning the correct function as intended. Let's do Fibonacci, right? Any questions so far? Yeah. By the way, I'm gonna post the code on the sample code on the server, but here's the code that you can see. Beauty of Vim, I can do development at the same time. Like I show you the factorial code on the left. I'm gonna show you the Fibonacci on the right. So this is Fibonacci code, right? Well, I'm gonna just show you this split window. Why not? uh, so int I, and I want to compute the Fibonacci of I, right? So the first thing I would do is scanf for I, right? And don't forget the ampersand, right, for scanf. Then let's do recursion first, right? Let's do recursion first. Printf fib of I is something. And then we're gonna define a function called fib, which takes int I as an input and would return what? So what do we do here? If I is 0, what do we return for Fibonacci of 0? Ah, thank you. That's another good optimization. If I is less than 2, just return I. Right? If it's 2, if it's 1, return 1. If it's 0, return 0. Else, return what? Fib of I minus 1, right? Plus fib of I minus 2. All right, should we test this? No, not February, it's called fib. Ooh, typo. All right, some error here. So let me go over. When you look at the error code, right, you see this part. It would tell you the file that generate the error. This is the line. That's the character in the line that has the error. So let's go to line 14 in fib.c. To go to line 14 in Vim, you do colon 14, it will go to line 14. Anyone spot the error? I forgot the comma. Here. Okay. Thank you. So I can now do this. No complaints. So I can do fifth of 5. That's going to be 5. Fifth of 6, 8. Right? Fifth of 7, 13. Fifth of 8 is going to be 21. Right? And let's do fifth of, let's say, 50. You see, it's taking a long time. This is not my screen. Basically, this is not the internet problem. It's still waiting for the result, right? It's waiting for the result. So computing fifth of 50, which is not a lot, right? It's quite a lot, but it's not huge. But it's still taking multiple seconds. Anyone want to guess why is that the case? Why is fifth of 50 is taking so long? It has many function calls that do the same thing over and over. If I want to compute fifth of 50, it means I probably have to compute fifth of 20 hundreds and hundreds of times, right? It may be more actually. So it means that there's a lot of repeated computation. So to combine what you know in algorithm, there's one technique called dynamic programming that can be used to solve this problem through memoization. I'm going to show you how to write Fibonacci using a loop, right? So I'm going to write another function called fibloop, which instead of running recursion, it takes I and return the Fibonacci of n, but use a loop. And hopefully I don't have bugs here. There was a bug in the earlier session that was pretty embarrassing. It's basically this is a stupid bug in the code about like loop index. So what do we do here? What do we do in a loop? One thing we might have noticed, right? If you want to compute fifth of 2, it basically is gonna be fifth of 1 plus fifth of 0. Right? And you can apply the same logic over and over and over. Fifth of 3 is going to be fifth of 2 followed by fifth of 1. Right? Fifth of 4 is going to be fifth of 3, right? Plus fifth of 2. Fifth of 5 is going to be fifth of 4 plus fifth of 3. So to actually do this loop, you start with fifth of 0, right? 4. Well, actually, do you need an array? Let's use an array first to simplify things, right? I'm gonna call an array fifth that has a size of I plus 1. I think a size of I is fine, right? Each one over here, each one would represent the Fibonacci of that value. So fifth 2 is gonna be what is the value of Fibonacci of 2? And you start from 0. If j equals 0, right? Then fifth of 0 equals 1. If j equals 1, fifth of 1 is going to equals 1 as well. Oh, sorry, fifth of 0 is 0, right? And as usual, we can do the same thing here, which is a little bit slight optimization. Basically, if j is less than 2, fifth of j is going to equal to j. Same thing, right? If j is 2, fifth of 0, if j is 0, fifth of 0 is 0. If fifth of 1 when j is 1 is going to equals 1. Else, right? Fifth of j is going to equal what? I mean, by this point, we computed fifth of j minus 1 and fifth of j minus 2. So what is fifth of j? Yeah, j minus 1, right, plus fifth of j minus 2. Notice this is not a function call. It just use the old value already. Oh, actually, let me do a block comment. Already computed, right? So there's no repeated computation, which is efficient. And then at the end, what do we return? At the end, j is gonna equal to I, but there's no fifth of I. There's no fifth of I. So what you return is fifth of j minus 1, right? Plus fifth of j minus 2. And I think this is probably the correct answer. Let's test it. To fifth of 5, right? So the loop version is 5. The recursion version is also 5. Fifth of 6 is the same, right? Fifth of 10, still the same number. Anyone confused? Why do I return this part? Anyone has a question about this line? So a quick explanation is basically inside this loop, right? Inside this loop, it would perform fifth of every single number up to I. So we have fifth of I minus 2, we have fifth of I minus 1, but we haven't finished fifth of I because when j equals to I, over here, we break the loop. You got out of the loop. So what we return at that point when j equals to I, we want to return fifth of j minus 1 plus fifth of j minus 2. So let's see how fast this thing can be, right? I want to compute fifth of 50. Right away, I have the result. Right away, I have the result. I'm still waiting for the recursion version, right? I'm still waiting for it, right? So this is one way you can basically integrate what you learn in algorithm class and see how you can improve the performance in your code, right? And let's just to double check that things are correct. Let's use fifth of 45, right? So it should be relatively fast. Still quite a long time, actually. Yep. So the number equal, which means we are correct, right? Uh, that's it for the class today. So we are gonna transition over to our in-class exercise. All right. So let's switch over to Discord. Any question about the demo before we move over to the Discord for the in-class exercise? Sorry. I'm gonna actually let me do one thing before we leave, right? I think it's already, yeah. So I'm gonna put these code in sample code slash 2021 T1 slash let's then need to make that first and then slash lecture 6 sample, right? And then I'm gonna basically copy over every .c file to that folder. So you can take a look at it. And let me double check that you can open the file. Yep, it's readable. So you can open the file and check out what is there and did it how did it get implemented. It will be in slash sample code slash 2021 dash T1 slash lecture 6 sample. All right, so you can check out the code later. We are now gonna move on to the in-class exercise. All right. I'm gonna stop sharing my screen and we'll be in Discord. All right. Any last minute question before we migrate over to Discord? No, I guess. Yes, no. Okay, so I think that's all for the lecture portion and the demo portion. I'm gonna switch over now. We'll see you all in a bit. All right.